So in this problem, we're told to evaluate the Riemann sum for f of x equals 5 minus 1 half times x from 2 to 14 with 6 subintervals. And then we're going to be taking the sample points to be left endpoints. We're trying to find L sub 6. And so the first thing that you want to do to solve this problem is just draw a number line because it's going to help us visualize what to do. So the lowest number on our number line is going to be our smallest number here. So our smallest number is 2 in our domain. Then 14 is going to be our biggest. So that's how I want you to lay it out. So smallest number, then your largest number. And then it tells us that we're going to have 6 subintervals. So let's split our number line into 6 different parts. So I try and split this into 6 different parts here. So we got 1, 2, 3, 4, 5, 6. So we've got it in 6 different parts now. 6 different intervals, right? So each of these are going to be an interval. And then what I want you to do is find what each of these values are going to be. And so in order to do that, what we need to find is delta x. And so basically delta x is just the change in x for each of our intervals. So if this is one interval, we can find the distance between it and then just add it to it. So delta x is what we're going to find. So delta x is going to be equal to b minus a over n. Let me explain to you what each of these are. So b is basically just the highest number in our thing. So b is going to be equal to 14. And then a is just our lowest, so 2. And then n is going to be equal to the number of subintervals. And so in this case we have 6. So n is going to be equal to 6. So this is going to be equal to 14 minus 2 over 6, which equals to 12 over 6, which equals 2. So now that we know our delta x, our change in x, is just going to be 2. So each of these are going to change by 2. So if this is 2 and we add 2 to it, our next interval is going to start at 4. Then if we add 2 to that, this is going to be 6, 8, 10, and then 12. And so now we laid this out. Now what I want you to do is we're going to try and solve. So L sub 6 is going to be equal to delta x times f of x sub 1 plus f of x sub 2 plus f of x sub 3 and so on. And I'll explain to you what these mean. So basically it's telling us to take left endpoints. So let me explain what that is. So the left endpoints, so that's basically just going to be the smallest value in our interval. So if we have different intervals here, the left endpoint is just going to be our starting value. So we have 6 subintervals, right? So we're going to have 6 f of x sub, and we're going to go up to 6, right? So you have these intervals here. You're going to take the smallest value in it. So if we have this interval, right? So from 2 to 4, the interval, we're going to try and find the left endpoint. So the left endpoint is just the smallest value. So in this case, it's 2, right? So we're going to find f of 2 as our first one. So it's going to be L sub 6 is equal to delta x, and we know what delta x is, it's 2, times f of x sub 1, which in this case is 2. So we're basically just finding f of 2. But let's look at the next interval. So now we want to add the next interval, and we're going to start with the smallest value. So the left endpoint is just where we start. So it's going to be f of 4. And then if we do the next one, it's going to start at 6. So f of 6. And you want to do this in the number of times you have the interval. So this is going to be f of 2 plus f of 4 plus f of 6 plus f of 8. And then I'm going to move down because I don't have enough room. Plus f of 10, right? Because we're just taking the smallest values. And then we have this one. This is going to be our final one. So f of 12. And then what we're going to do is add all these together and then multiply it by 2, and it's going to be our answer. So hopefully you understand that. So let's go ahead and calculate. So L sub 6 is going to be equal to 2 times, let's find f of 2, right? So it's our left endpoint. So f of 2, we just want to plug into our function. Our function's 5 minus 1 half times x, but we're calculating it for 2. So if we plug in 2, 2 times 1 half is going to be 1. So 5 minus 1 equals 4. So the value is going to be 4 for our first one. So let's look at the rest. So this is 4. Then let's find f of 4. So it's just going to be 5 minus 1 half. We're doing times 4. 4 times 1 half is 2. 5 minus 3. 5 minus 2 is going to be equal to 3. So we have 4 plus 3. And then let's do the next one. If you notice, this is just going to be a pattern. So it's just going to decrease 1 each time because we're minusing by 1 half. So 5 minus 1 half, if we plug in 6, it's going to be 5 minus 3, which is 2. And then if we just keep going down, we're doing it 1 time, so it's going to be plus 1. Right, you can see that if we plug in 8, this would be 4. 5 minus 4 equals 1. And then we have, I'm going to move down. Then if we plug in 10, it's going to be 5 minus 5, which is 0. And then we just have one more. 12. If we plug in 12, it's going to be 5 minus 1 half times 12, which is 5 minus 6, so minus 1. So basically, Now we got all our values. We're going to add them together and multiply by 2. So we can see that our minus 1 and 1 are going to cancel, and then 0 doesn't add anything. So we just have 2 times 4 plus 3 plus 2. 4 plus 3 is going to be 7. And then we add 2, so it's going to be 9. So this whole thing is going to be equal to 9, so it's 2 times 9. And 2 times 9 is going to be equal to 18. So L sub 6 is going to be equal to 18. And that's going to be the answer to this question.